Yo, what's up, guys? So today we'll be talking about equations, which is one of my personal favorite things of algebra. And if you like this content, consider subscribing. But now let's get into the video. So now we're going to talk about rational equations. So you may remember this from Algebra 1, but it literally just means an equation with a variable in the denominator. So let's talk about some. Let's do a little overview. So if we have x minus 1 divided by x plus 3, and let's say that's equal to 3/7, okay? How do we solve this? Well, what we do is we start by multiplying both sides by the denominator. So boom, so times x, oh sorry, that was really bad, x plus 3, okay? And so these cancel out and these multiply. So we're left with x minus 1 is equal to 3 times x. We can FOIL this right here. So 3x plus 9 divided by 7. Okay? And now what we can do is we can just multiply both sides by 7. Yo guys, so from here I was going to go on to tell you how easy this is, and it's just simple algebra, but as you could see, apparently it isn't simple algebra for me. What it should have been is 7x minus 7, and I would have subtracted the 3, so I get 4x, and that would have would have added the 7, so then we get 4x is equal to 16 divided by 4, and we get x is equal to 4. So sorry about that. When working with rational equations, you must make sure that you see your excluded values. What excluded values mean is that, as x can be anything, right? So when x is in the denominator, so when you have something over, we have x minus 1 over x plus 3. If x were to equal negative 3, so if x were equal to negative 3, right, that's negative 3, that's negative 4, divided by negative 3 plus 3, and that's 0. So you're dividing by 0, which you cannot do. So there are some values when working with rational equations that you cannot use, and these are called excluded values. So you can just write this as x cannot equal, that was bad, not equal sign, x cannot equal negative 3. And so depending on who's teaching you, they might want you to include that. Now let's talk about functions. So you can't talk about equations without talking about functions. So let's inverse functions. So you guys may be aware of this. Inverse function is basically where you flip the x and the y. So if we were to have 2x, y is equal to 2x, then the inverse would be x is equal to 2y, and if we were to rearrange this equation, we get y is equal to 1/2 x. Okay, but what we're going to do now is we're going to do that with more complex equations using the same method, okay, which is just substituting the y for x and x for y. So let's say we have the equation y is equal to 3x minus 4 divided by x plus 5, okay? So how can we find the inverse function? Well, we have to first reverse all of the variables. So we have x is equal to 3y minus 4 divided by y plus 5. And now we're just going to solve this like any other rational equation. So we have y plus 5, and we're going to times y plus 5. Oh, that's bad. 5, so these cancel out. And here we're left with x, y plus 5x is equal to 3y minus 4. Now we're going to get the y's on one side of the equation and the x's on the other side of the equation. So what we can do is we can subtract this 5x, and we can subtract this 3y, and sorry, we've got to subtract 5x from this side and subtract 3y from this side as well. So we're left with xy plus negative 3y is equal to negative 5x minus 4, okay? And from here we can factor out the y. So we can factor out y times x minus 3 is equal to negative 5x minus 4. We can divide by x minus 3 for both sides, and we get our answer. So the inverse of the function 3x minus 4 divided by x plus 5 is negative 5x minus 4 divided by x minus 3. And some people don't like having, two negatives in the numerator. So if we multiply the numerator by -1 and the denominator by -1, then we can rewrite this as 5x plus 4 divided by 3 minus x. Both of these are valid answers, so whichever one you want to use or feel comfortable with, you can. Now let's talk about square root equations. So these may seem simple at first, but let's try one, okay? So we can do the square root of x, and that is going to be equal to 3x minus 1, okay? So to get rid of the square root, we square, right, both sides, square. So we're left with x is equal to 9x minus 6x plus 1, okay? And now we can subtract x, and that's equal to 0. So we're left with 9x minus 7x plus 1. Now what we can do is we can plug this into the quadratic equation. So let me just write that up here. It's negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so let's solve this. So negative b is positive 7 plus or minus the square root of b squared, which is 49, plus negative 4, what's a, is 9, and what's c, that's 1, okay? So we're left with divided by 2a, which is 2 times 9. So we have 7, here, let me give it more space. So divide this by 2 times 9, and so then we get 7 plus or minus the square root of, this is going to be 49 minus 36, and 39 minus 36 is 13. So we're going to get the square, so we're going to get the square root of 13 divided by 18, okay? So our two solutions here is 7 plus the square root of 13 divided by 18, and 7 minus the square root of 13 divided by 18. But there is a very important thing that we forgot to do. We have to plug this back in. So you may be thinking, okay, well, what's the point of plugging this back in? Well, when you square a square root, some of that information is lost, right? So when we think of the square root of, how about 16, we think of the principal square root, which is 4. But when you're working with square root equations, it's not always the case. So let's plug this in. So if I write the expression in my calculator, 7 plus the square root of 13 divided by 18 is equal to about 0.59. Okay, so this is about 0, I can write that, 0.59. Okay, so now let's plug this in. So if we do the square root of 7 plus the square root of 13 divided by 18, we get about 0.77, okay? And now if we plug it into the 3x minus 1, if I plug that into the 3x minus 1, 0.59 times 3 minus 1, that is about 0.77. And so we can tell that that matches, okay? And now let's try it with this other one right here. So let's do 7 minus the square root of 13 divided by 18, and that is equal to a smaller number, 0.18, or about 0.19, okay? So now let's plug that in. So if we do the square root of this answer, we get about 0.43, okay? And now let's do 3 times our answer minus 1, and we get negative 0.43, which is not equal. So the problem with this is that we solved for this equation right here. We solved for x is equal to 9x minus 6x plus 1. We did not solve for this equation up here, because when you square when you square an equation, some of that information is lost. Because if I were to example, 2 squared is 4, and negative 2 squared is also 4. So these are equal, right? But if I were to find the square root of them, right, 2 is not equal to negative 2. So when you square numbers, some of that information about positives and negatives is lost. And that's why you should always be careful when working with square roots. And as I said before, there are some solutions that you get that will not work for certain equations. These are called extraneous solutions. And now let's make equations that have extraneous solutions. So let's say that we have, when x is equal to 4, we're going to solve for d so that the equation 6x plus 49 is equal to 2d plus 4x, so that it has an extraneous solution. So, well, how can we solve this? Well, as we know, we use the principal square root, which is just the positive outcome. So square root of 16 can be plus or minus 4, but we normally just use positive 4. For equations, especially square root equations, we find that we end up getting a negative outcome. So all we have to do is set this side to negative, okay? So we have to plug in for x, okay? So 6 times negative 4 plus 49 is equal to 2d plus 4 times negative 4. And remember, we're saying this to negative because we want to find an extraneous solution. So we're going to solve this, solve the square root, which is negative 24 plus 49, and that gives us 25, or the negative square root of 25, and that is equal to 2d plus negative 16, okay? And we solve that, we get negative 5, that is equal to 2d plus negative 16. We're going to add 16 to both sides, add 16, and we're left with 11 is equal to 2d. We're going to divide by 2, divide by 2 on both sides, and we get d is equal to 5.5. And so that is the value of d to make this equation have an extraneous solution. Okay, so thanks for watching. So today we covered rational equations, inverse functions, square root equations, and what extraneous solutions are. Next video I'll pick up talking about functions and systems of solutions.